Okay, last time we introduced the learning curve rate as a value that would take on, uh, and we'll do one, and then actually what I'll do is uh, increase the decimal places here, just to show you how this might work. Um, and so what we'll do is try different values, say zero point 0.9. So again, we'll format this all to two decimal places, 0.85, 0.8, 0.75, and zero point 0.7. So when we calculate our value for B, then what the formula then would be to take the natural log of the learning curve rate divided by the natural log of 2. So the value for B then becomes demonstrate. So in this case, when we have a learning curve rate of 1, that is, there's no learning, we have something raised to the 0 power in our formula here. So the number of units, so how long will it take? Well, if something takes 10 hours to do the first unit, well, then we would have 10 times 1 to the 0 power. 10 times 1 is 10. If we have 2 units, then if it takes 10 times 2 to the 0 power, anything to the 0 power is 1, so 10 times 2 would be 20. It would be I'm sorry, 10 would be, anything raised to the 0 power is 1, so 2 to the 0 power is 1, 10 times 0, it continued to be 10. So if we calculate this formula following the B construct here, notice that as the learning curve rate declines, this exponent becomes larger in absolute value terms. And so this is where students sometimes have some challenges, because they see this learning curve rate as as something where, okay, if it's a 90% learning curve, well, then that means it's well, that's a lot of learning. Well, but 90% learning curve rate is actually lower than the amount of learning is lower than that is, say, a 75% learning. And so this is what's key here, is that when we're developing this model, that's what we're talking about. Is think about it in terms of how much time it's going to take. So it'd be taking 75% of the time relative to the previous unit. And so, and this is something to also keep in mind, is sometimes if you have an estimate, say, back to the example of doing tax returns, I mean, there's something that these will take some time, and at some point learning will stop. There's still going to be a certain amount of work that will be undertaken, and it will take time. It's just that you're able to do it so quickly. Just as you're working through a problem in Excel, it's going to take a certain amount of time, no matter how quickly you become proficient with Excel. But this exponent value, because we're going to be able to try a few different things here, but what I wanted to do is give you some relative ranges of uh, of our different values for B, and what this may mean, as we go through and estimate a learning curve.